In this video, we're going to find out how much tension is required in a rope that is moving upward with an acceleration. So here we have a 500 kilogram mass that is supported by this rope here, and this system is in an elevator, and the elevator is moving upward with an acceleration of 2 meter per second square. So now let's calculate how much tension is required or how much tension is needed. So we have to find out the tension. The mass is given, that is 500 kilogram. The acceleration is 2 meter per second squared, and g value, acceleration due to gravity, is 10 meter per second squared. And I have chosen to 10 meter per second squared rather than 9.81 just to make life easier and calculation faster. Okay, so how are we going to solve this problem? All you need to understand is the Newton's second law of motion. And what does the Newton's second law of motion tell you? The Newton's second law of motion tell you that the force is equal to the mass time acceleration. The mass time acceleration. And in this case, F is the net force, the total force acting on the object. So let's find out what are the forces acting onto this suspended mass. So we have this mass here. And what is the direction of the weight? The weight is always downward. So I have drawn the direction of this force is mg. That's the weight, and that's the downward direction. And this weight is supported by tension in the rope. And what is the direction of the tension? This is in the upward direction. That's the tension. And this acceleration and this elevator is going upward with a 2 meter per second square. So we have now drawn all the forces acting onto this mass here. So now let's apply the Newton's second law of motion. That's again here is the Newton's second law of motion. And all you have to figure out is the net force. So the tension is in the upward direction and the weight is in the downward direction. So what is the total force? The total force is now T minus mg. And here I have chosen all the upward direction to be positive for simple reason because acceleration is in the upward direction. And in fact, you can choose the others too. So the T minus mg is the net force in the upward direction, and that is now equal to ma. So I have to solve for the tension. That will be equal to mg plus a. The mass is 500, g value is 10, acceleration is given, that is 2. So if you do the math, you will get the tension to be 6,000. And this Newton is the unit of tension. Tension is a force, so its unit must be the Newton. So now what happens if the elevator was not moving? If the elevator were not moving, how much tension it would have? So I can calculate that one quickly. So in that case, if the elevator was not in motion or was not moving, then the tension would be simply equal to m times g, or m is 500, g is 10, so it would be 5,000 Newton. 5,000 Newton. 5,000 Newton. And so here, this is when the elevator is not accelerating. So when does a system do not accelerate? Either it is not moving or it is moving with a constant velocity. So as the elevator is moving upward or downward, if it is moving with a constant velocity, then it will have this much tension. But if the elevator is accelerating, then there would be more tension if it is going upward. And the opposite things happens if the elevator goes downward, then the tension in the rope would be smaller. So this is it from this video, and do not hesitate to contact me or write down your comments if you have any question in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you very much.